So far, the pipeline we've created has two steps to it. This make the polynomial features step and the perform the linear regression step. And what I want to do is I want to add a third step to this. Okay, it's going to be in the middle. So after we generate the polynomial features like the x cubed and the x to the fourth, I'm going to add in a scaling step. So I'm going to give it the name scalar, and then this is going to be StandardScaler. And I guess it won't work right now as I've written it because I haven't imported the StandardScaler. So let's do that. So from sklearn.preprocessing, import StandardScaler. And notice how we do these pre-processing steps first, and then we do linear regression. And that should make sense based on them being called pre-processing. So these are things we do before we actually fit the linear regression model. Okay, great. And now we have to fit it again. So pipe.fit. Inputs are going to be just this x column. Outputs are going to be the y column. Okay, great. And then let's check the coefficients in this case. So pipe.named steps. Then I want to check the reg here. So reg, and then I want to check the coefficients. And so here you can see that they are much bigger now that we've normalized all of them to have standard deviation 1 and mean 0. So for example, the degree 10 coefficient is let's see, I guess that's 1,000 times negative 4.57. So this is negative 4,573 something. So here we really are getting these large coefficients. And so in the next video, I'm going to show how we can combat these large coefficients by changing the function we're trying to minimize. Instead of trying to minimize the mean squared error, try to minimize some function that is mean squared error plus something in terms of the coefficients. And by minimizing that function, we'll get much less overfitting in our model.